Hello, I'm here with Rob Conery, and he's the author of an interesting book entitled The Imposter's Handbook.
Mm-hmm.
What is that, and what drove you to drive it?
To
write it?
Well, both really. I've always wanted to have a computer science degree. I'm a geologist, and so I came out of school. I was a geologist for about 8 years, and then I started playing with databases, and next thing I'm programming stuff. And I've always had this just big hole, or at least I felt like there was a big hole in what I knew. And I thought someday I'm going to sit down, look at a curriculum for a computer science degree, and I'm going to do it. Because, you know, why not? Sit down with some books, read some things. And as I started to do it, I started to just write down what I was learning. And then I went and bought an iPad Pro with a pencil, you know, because I wanted to draw what I was learning too. Because when you're by yourself learning something, it's kind of hard. It's like an echo chamber, you know what I mean? And I thought, you know, I'm going to turn this into some blog posts because I think it'd be kind of fun. And then people can tell me, oh, you're wrong and whatnot, and I can learn more. And the next thing I knew, it became a book, and there it is. It's kind of been released.
It's pretty amazing how it is. I mean, I published 5 books, and it was an absolute pain.
Mm-hmm.
And nowadays, with self-publishing and like press on-demand services and things, and like living books that you can update yourself to people, even publishing on GitHub, it's pretty incredible. And most of the books that I'm buying nowadays are like living books, so you get new updates every week, which is so much better than have one that like, okay, that's the end of all reasoning, and it's going to be the book forever.
Exactly.
I mean, I have the same problem. I've been always busy in this market. I've been doing it for like 18, 20 years, and I don't have a CS degree as well. And I always are like, okay, I should know what I'm doing here. And I can safely say, with my JavaScript book, I used JavaScript professionally, paid for years, and then when I started writing it, I started understanding what I'm doing because I had to explain it. It's much harder to actually get along with that. The problem is right now, all of this, with our market getting bigger and IT being like the sought after work and everybody is looking for people to hire, it seems like the patterns and the algorithms are getting much more excitable for people in interviews. Like I've been in interviews where they gave me like a pen and say like, okay, can you solve a Sudoku thing on the whiteboard? And I was just standing there like, have you looked at what I've done the last 15 years? Like I've proven that I can do this. Why is this a thing? And do you think it's just a matter of like that we have so many developers right now, we have to find something to measure people against?
I think when people, now I don't know, because when I interview people, I mostly have just wanted to know what they're about. But I think when people ask algorithm questions, I think they want to see how someone internalizes what they're, like, to solve a problem. So for instance, when you brought up Sudoku, there's an algorithm that goes into solving a Sudoku grid. And I just learned this like a few months ago. And that algorithm is actually really, really complex. And so complex that it, you know, doesn't scale very well. But instantly I know now, when someone brings up solving something, let's say, like here's a problem I want you to work on, I can check down a list of things that are really hard versus things that maybe I could do versus things that I can't. And so I'm able to speak to that just a little bit better, if that makes sense. So software patterns and stuff, I would say, yeah, we could argue whether those things are even relevant. But the algorithm things, I'm starting to find that it really does change the way you think about a problem, for instance.
Does this also mean that our products are becoming more complex? I mean, most of these algorithms are older versions and are older solutions for when the hardware was slow or you had to save a lot of memory. And it seems like we're building much more complex systems, so we're going back to these mathematical solutions rather than just building it and hoping the computer scales around it. Yeah.
Well, I mean, if you look at what we're trying to solve back in the day, let's say in the 90s, you know, we just wanted stuff delivered to our house. You know, then Webvan was like instant, and we had food, and that was cool. And then all of a sudden, we started talking about networking and the social graph with Facebook, and it's growing and growing from there. And now we have this predictive analysis stuff going on, and mobile. And I was just playing Pokemon Go the other day, and you know, I don't ever play that. My kids were like, "Come on, Dad, try it," you know. And I was just marveling at this thing and what it can do, and with spatial analysis and all. I'm like, "Wah!" Yeah, it's getting really hard. And I think under that, yeah, our algorithms and things they're always there. They're always the same. And it's funny because I was looking on Stack Overflow when I was writing about traveling salesmen. And that's a classic interview question, like, how would you do this? And someone actually said, my boss came in and he wants me to actually implement traveling salesman for our app. How can I tell him this is a dumb idea? You know, it was pretty funny, but you know what? A year ago, I would have just kind of puzzled at that. Like, why is that a dumb idea?
So there's a cargo cult going on as well. People are like, okay, you got to use these patterns and these, or not a professional developer. And it's funny how many patterns are being evolved on Reddit and on Stack Overflow every day. It seems to me, though, there's a massive discrepancy of what we learn in school and what we learn about computers in school and what we actually need to do in the market right now. Is this a problem, or is this actually the idea of academia? I mean, I've never been in university, so I feel like, is this the place where you should think about the hard problems that never come up and actually come up with creative solutions for the next things to come? Or is it something where we should teach people the things so they can hit the ground running and make some money and products later on?
So I have a funny story about this. So my brother is a computer science professor at U of O, and he teaches every level of program, or every level of class. And I asked him, like, what do you guys use? What do you do? And they use Python, they use Ruby, they solve all kinds of stuff. They do some very interesting things. And I found that it's not the same CS degree that maybe when you and I were younger, that you would, you come out and all you know is C and VAX or something like that. It's not the case anymore. But the one interesting thing, we got into an argument about, I love this, the term separation of concerns. And he started to tell me, like, well, CSS is a great separation of concerns. And I was like, no, Dijkstra's definition. And I started quoting him Dijkstra, and he just looked at me like, you need to stop reading all this stuff, And so the point being is I was trying to come at it from, look, over the last 20 years as I've been programming, I've come to understand these things, and this is what I do in the real world. And he was coming at it from a purely academic standpoint. And it was interesting, the discussion we were having. We could not communicate, literally could not communicate. So I would say that is a problem for people coming out of academia, not understanding the industrial application of what they learn. I think that's changing a little bit, but I do think, there's still a bit of a gap when people come out of school and like, what are you guys doing? Why are you denormalizing your database? Or what, why are you breaking this thing? You're messing with my Zen, man. And,
to quote the neutron, you're messing with my Zen thing. But it also feels that this is actually permeating through in bad communication later on.
Absolutely.
There's a lot of like arrogance and a lot of like, well, if you don't use the right word, we're not even going to listen to you. And we're striving to make our market more diverse. And at the same time, we've got like very adamant, white, angry people saying like, this is how we have to do it and there's no other way of doing it. Is this maybe an issue that we should fix already on the academia level, on the university level? Because re-educating people is much harder, isn't it?
I find it on both sides. I find that people, when they react strongly like that, it's always from a point of insecurity and fear. And so like from my perspective as a self-taught developer, if someone came at me with, you're doing X, Y, Z wrong, and throw theory at me, I don't know what you're talking about, so I would push back, because this is the way I've always done it, and I don't know what you're saying, so I must be right. Whereas they will come at me and see something which is the exact opposite, which is, it was like a show I watched last night on winemaking. California winemakers will throw whatever grape together, right? And French and German winemakers are like, what are you doing? And so it's kind of the same thing. People that are self-taught are willing to write the dumbest code. I'm one of them. Whereas academics would look at this and go, what do you, no. And so, that gap, there is this tension, but I think it's on both sides. And I do think, being positive, you can harness that. You can definitely get these teams together to explore what they both think can't be done. And then boom, something amazing happens. I think that's neat.
Yeah, there's different departments for it. And I mean, I'm working with the machine learning team here right now, and I'm an okay programmer. I have no idea what they're talking about. They see me as a god because I know how to write things that make computers do things. So working together really, really is a good thing there. And a data scientist and a programmer, to me, are totally different skill sets.
Absolutely.
And fun enough, the diversity in the machine learning team is bigger than in the development teams that I see. Also because there is a lot of competition and competitiveness, which I never understood. When people like, oh, you're not using this pattern, I can make
Right.
my program scale for the next 50,000 users. And I'm like, do you have 50,000 users?
Right.
No,
No,
but
but-
they will come,
right.
and you're like, how do you know? Like, you don't even
Yeah.
have an interface that's inviting. So it's quite. We try to predict a lot of things, and we're very aggressive about it. And we also strive for simple solutions as developers all the time. We look at hard problems, but we want to have one solution that fits it. And it's kind of tough to find that in the real world, I think.
It is. I swear, working with programmers, I think working with any other person is a practice in psychology where they want to feel involved. They want to feel like I can contribute, you know. It can come down to, are your braces on the same line or not? You know, the Krebs, or what is it called? K&R, right? Krebs, I don't know where that came from. Anyway, yeah, they want to know, you know, they look at the brace, well, I can't do this, the brace, and you get in a weird discussion about braces, or even, you know, who was I just talking to about data analysis, and I couldn't even get past what I was doing, and they said, well, how are you doing that? And I'm like, it doesn't matter, let me tell you about the results. And no, so it's interesting, like, for me, the challenge psychologically is take a step back, make sure the person feels included. Sure, I'll look at braces on a different line, whatever you want to do, it's okay. And once that starts happening, I find that actually people start working together really well. It's weird. Psychology is a strange thing. You know what I mean?
I always found myself looking at algorithms and looking at like clever programming, and I'm just like, I'm not excited.
Yeah.
You know, I started writing games for Commodore 64, making like little sprites jump around and crash into each other, and that got me excited. And fiddling with numbers until the colors changed or I managed to do other things. Brett Victor is an interesting guy that actually gave a talk a few years ago about how we should build interfaces that the input is the same as the output, that you write your game by playing it, and these kind of things. And he has also a course online called Learnable Programming, which starts with visual things. It starts like, okay, here's how you make a circle and paint a circle, and he explains a for loop and a while loop by explaining the visuals that it generates. Do you think this is a way we should bring computer science more to people, that we think more of the outputs rather than the thing? I mean, there's a lot of hackathons where people build like little robots and drive those around, and there's Logo used to be in the past, and there is MIT has this program for kids that you can just snap little puzzle pieces together, and that becomes a loop and an if statement. It feels like those things are frowned upon by real programmers, but I think if we want to scale the programmer community, this is a good way to get people in who are more on the creative side.
Yeah, well, I think it touches on exactly what you're saying, the creation. Something I thought about a lot. I devoted, I think about 100 pages to the genesis of computation. And not a lot of people know this, but the computer was invented in 1835, I think. You know, Charles Babbage wrote out this whole gear structure, this steampunk computer, and the specifications for these cards. It was never actually built, but and his accomplice was Ada Lovelace, and so she wrote the first program on a punch card. Well, that's arguable. Historians argue about that, but anyway, she wrote this program for punch cards, and computer scientists have analyzed that and said it's Turing complete. What you can do with those punch cards, which twists your mind around that a computer was built that long ago and kind of forgotten, and then Turing came along, and then at the same time, Alonzo Church came with Turing with lambda calculus at the same time, and they both discovered the same principle. And then it's just amazing when you walk through that whole story. It fires you up. I mean, it makes you feel like we are in something that is absolutely changing to the human condition. Like what we're doing. When you get into computational theory and you realize that we are trying to tell something how to think, we are recreating, it is really intoxicating. So to me, touching on that is probably one way to get more people into computers. In other words, who cares about the braces? You know, who cares about whether the algorithm and patterns are right? Look what we're doing. We're making this in human history. Who's ever done this before? Well, we are literally building something out. And who knows that it could come alive someday and burn the planet up, but who knows? You know what I'm saying? Like, I think, to me, that really excites me. The whole genesis of computation, I think, is something that really should be talked about more.
Yeah, I love that the Ada Lovelace test. Everybody talks about the Turing test, but her test is that a computer becomes creative, and people cannot explain how it was creative and what it did. There's no pattern to it, and that's going to be interesting when I look at like the analysis that people do of like making computers paint, making computers compose. And I'm giving a talk soon about the job market and automation and machine learning and what it means. And the creative jobs are the ones that are safer from automation than others, but not for long, I think. And it's when you look at, like, for example, news items, they are written by computers already. Some of the pop music is actually written by computers as well. They have algorithms in them that sound good, and they all sound the same sooner or later. So it's fascinating to see these tests. And yeah, coming onto that, like seeing that machine learning, artificial intelligence has taken over every aspect of our lives and our jobs. If we build systems that are based on these very strict patterns and algorithms, isn't that something that sooner or later will be programs writing themselves? I mean, IDEs give us a lot of boilerplate already. And I always wonder, like, why should I spend time on that when it's a very simple, easy to follow thing? I could just tell the machine, follow this pattern and generate the code for me.
Yeah. See, this is where a lot of the viewers and the people listening to this are going to think I've lost my mind. But
well, Elon Musk says we're in a simulation, so you have to go somewhere. Exactly
where I took this whole argument in the book I wrote, because, you know, as what we know from science is in the natural world, and as a geologist, I learned this through and through, that patterns repeat throughout, right? And we know this. And the creational pattern is something that, if you look at the genesis of life and everything that has come before, we kind of are guessing, of course, we don't know. But if you look at the result of what we're doing now, which is we're just doing this. We don't know why we're doing it, but people are building computers just because. And then, like you said, they're getting more and more involved. They're getting more and more complicated. Is this something that we're driving, or is this something that's just naturally happening? Is this a pattern that is cyclically repeating? The book that blew my mind when I started watching or investigating more of this is Gödel Escher Bach. Did you ever read that book?
No.
He talks about recursion and paradox constantly, and basically the punchline of the book is he calls these recursive things strange loops. Where if you look at an Escher painting, you know, the waterfall feeding itself, there's an audio version of that as well, where it's like the THX opener of Lucasfilms, right? That is an audio illusion, and it's a self-referencing, so it sounds like it's constantly going down, but it's not. You see this in Gödel's incompleteness theorem, paradox, a set of all sets containing itself. That's not the same thing, but anyway, the idea is these paradoxes underpin a lot of things, and the question becomes, is our creation of programs and software and computers right now this paradox loop that is spinning itself out until all of a sudden, we don't know why it happened, but yeah, computers can now think for themselves. Like you said, programs writing themselves, things starting to happen, and you're like, what's going on? See, this is where you're going to think I'm absolutely nuts, but I just sat there at night just like, this is crazy. When you look at history and you think about what, you know, reading these books and these mathematicians and logicians and Plato, right, all talking about the nature of creation and what's happening. So to bring it back to the Elon Musk comment, you start looking at that in a different way. Like, if we're creating these computers and if it is following the same pattern, did that happen to us? You know, and you kind of look around like, hello.
Well, if I look at politics right now, there's some bug somewhere. There's something going very wrong. It reminds me of This Island Earth, that old science fiction movie where they send the machines to humans, and whoever can actually build them are the scientists that are ready to communicate with the aliens. I think we're getting completely off track here, but it's an interesting theorem to see, like, how much can we automate ourselves? And then also, of course, when you can automate something like that with a machine writing itself, is it even necessary? Or could it be something? I mean, we've done that with video cards. I mean, we've written a lot of like loops and all kind of things, and now we got like vertex renderers and these kind of things on the cards itself. So the algorithms become parts of the chipset rather than having to be written every single time from scratch and just talk to a painting. So to a painting chip. So it's an interesting thing that we automated machines much more that way, and maybe code will do the same thing. One big worry of people is that they can't keep up with the pace of the market.
Mm-hmm.
It's ridiculous how fast it is, and when I look at like books, by the time they're published, they're outdated. Unless so you have to. It's quite funny when you publish books and people are like, oh, you wrote about that old thing, and I'm like, well, I started writing it a year ago, and it takes 1.5 years to print the thing and the marketing material of my publisher to get through. And the thing is, there's some truths that are fine in books, and they actually can write about, and they stand the test of time. How do I look at something moving faster? I mean, like, how do I find online materials that are trustworthy? Because there's a lot of, like, oh, this is my solution and it's the best one ever. I mean, the great example is like I call this a full Stack Overflow developer that just copied and pastes from Stack Overflow and puts it in and hopes it works and changes some numbers around.
Yeah.
But we've come that way, and at the same time we're talking about quality of code. So is there a way to find out? I mean, upvotes can't be it. I mean, we have all these fake currencies where people get excited about getting smiley faces for their code that might be terrible.
That's a great question. I had this discussion with my brother yesterday because we were arguing about NP hard problems, you know, and the halting problem, and whether the halting problem was NP hard. And I said, well, I think it is. And he said, well, where did you get that from? And I said, Carnegie Mellon University lecture from a professor. You know, but my brother is a professor as well, and he just kind of shrugged it off. And the interesting thing is, the more we talked about it, the more we realized there is no correct. I mean, you give up on the notion of correct and whether it's right. Then you start to see it in a different way, which is...
So define correct by effects?
Yeah, maybe. Well,
how much damage does it cause?
Yeah. Yes, exactly. How happy does it make me when I create this thing? So I was just writing a chapter before I came here, because I'm still writing this book. It's still growing, about learning a new language. And I said, the first thing I said is give up on the decision of whether this language is the right one to learn. And I said, you know, Go, Rust, Swift, Elixir. You know, all these languages are great choices. Just choose one and go with it, and you'll either like it or you won't. There is no right answer. And I think that is true for so many things. Now, I know a lot of people out there are going to say, there's always a right answer to 2 + 2, which, of course, but...
It depends what radix.
Yeah, well, the only thing I've been able to do is, because I've had to... Stop that. So you just broke my brain. See, that's the curse of like studying all this stuff. I'm like, I know what it means. I'm going to ignore it. Oh, yeah, see, you just did it. You just broke my brain. The only thing that I've been able to do when writing this book to check on the claims that I've read is to cross-check it 4 times. And 4 times is my rule. So if I'll read it on Stack Overflow, someone will post an answer and usually give a reference. I'll read that reference, and then I'll look at the point that's made. And then I'll say, okay, well, that's interesting. And then I'll go and Google it independently, usually land on Wikipedia. I skim the article because I don't trust Wikipedia very much, and I go straight to the references. And if I feel like if I land on a white paper, then I feel like, okay, some professor somewhere or some notable person, researcher somewhere was willing to put their career on the line to say this. So that gives it weight. Is it correct always? Never. Ever will I ever believe any of this is correct always, because something's going to prove it wrong at some point. So I kind of just go with it.
Also looking at the date sometimes is a good idea, probably.
Yeah,
like,
exactly.
It's like
well, what did I look at? The CAP theorem. I was researching CAP theorem, and the person who wrote it, names escaped me, but he wrote another follow-up to that 12 years later. And he said, well, you know, the trade-off to best of 2 of 3 in the CAP theorem, that doesn't really apply anymore because, what is it, partition tolerance, our networks are so good. It's one of the terms, I can't remember, but anyway, he basically said you can just forget that. Just go with CP systems, or one of the two. And I was like, well, that's interesting. So he basically kind of just looked at his own paper and said, don't worry about it. And
nice.
Wow, okay. That was a foundation of distributed databases forever.
Well, one thing I found enticing about the book title is that, like, okay, I can do all these things without having to look it up, but this is not what the book answers, does it?
Well, what it is, and I've tried to be super careful about this, this is my journey. And I even say at the very beginning, there's going to be people disagreeing with me, and then I pop a GitHub issue link, and I say, if you ever find a problem, just go and have a look at the issues, and other people might have brought it up.
People disagreeing with you online? That never happens.
I know,
it's normally it's not, and it's always quite well behaved as well. It's not.
Honestly, I have to say, I was blown away. Even the diehard Unix people, and I don't mean this as a slam, But when you discuss Unix and specific things within the Unix realm and you get it wrong, you're dead. And so I decided, whatever, I'm going to go and discuss the differences between the distributions of Linux and BSD and all those things, right? And I forgot what the exact topic was, but within an hour, I had a comment. And the comment started off very nicely. And he said, I don't want to be a jerk. I really appreciate your effort, but burn this chapter to the ground. And it was great, because underneath his thing was all his reasoning.
Okay.
And it was brilliant. And I was like, dang.
That's the great thing when you can take other people's content and make money with selling a book about it.
Right, well, that's true, yeah. Can I take this? And, well, he was right. Well, the funny thing is, I removed the chapter because it was distracting from the whole thing.
Well, that's my way of writing anyways. I write something, I came from radio journalism, so I basically make a stream of consciousness, I write everything down, and then I go through it 3 times and delete everything that's not necessary, and then I start blogging.
Right.
It's a very interesting way of, like, instead of torturing yourself trying to understand and making the perfect sentence, just let the thing flow and delete whatever. That's sometimes how I code as well. And it's not a bad idea at times. Just make the thing work and then optimize it bit by bit after you looked at in development tools what it actually impacts in terms of performance. Instead of just saying, like, okay, I gotta optimize this loop before I go on, and then after the week you haven't written any code at all.
You know what's interesting, to follow that up, one of the things I had with a lot of friends asking me about, like, what are you writing about this? And I said, well, here's what I've covered so far. Oh, no, you can't. They have a very strong opinion about what I can't do, what I can't say. Don't do this, don't say that. I'm like, okay, well, will you proof it? Sure. And you send it to them to proof, they don't proof it. They don't even look at it. And then you call them up and, like, so let me ask you point by point, here's the thing I'm doing and saying, and da-da-da. And they're like, well, I actually don't know. You might want to check with so-and-so about that. And then you kind of find, like, wow, your reaction was so strong, but you really didn't, how deep did you know that subject? It's weird. It happens a lot.
I think we like to disagree online because we're actually not seeing the other person, and we're not seeing that we're impeding somebody or we're actually affecting somebody. We did this when I worked at Yahoo in England. We had a system to find, like, where to find lunch, and when we asked people for where to go to lunch, it was endless discussions. When you give people 5 solutions and say, like, vote the ones down you don't want to have, then within 3 minutes you got a solution.
Yeah, or you say, we're going to this curry place, you want to come? Yeah.
Sometimes, like, giving people the choice to downvote things is a better option than giving them 10,000 choices. Now, on a more dangerous thing, imposter. I mean, it's a humorous play on, like, it's the Imposter Handbook. Like, okay, you can get along with it, but imposter syndrome is a big problem, and it's actually crippling people's careers and their mental well-being. I suffered from it myself because I just basically, every time when people, doesn't happen often, but when people say I've done something very, very, very good and I didn't put much effort into it, I feel like I'm a fraud myself. Or even worse, when a director of your company comes up to you and praises you for the amazing job that you've done, and you basically want to delete that thing, every single line, because it's horrible and you had to finish by a certain date. We get praised for things that we don't feel proud of, and that is a big problem. What can we do about this? Is this something that we just being aware that it's just an issue that you have, or making sure that you only give praise and quantify it as well?
Yeah, there are actual. Okay, so this is funny because this is one of the chapters I meant to put in the book, and I waited just because I wanted to get it right. I just finished writing it today. I just smithed it and put it on there. A whole chapter on imposter syndrome, exactly. The whole book, so I have to preface this, the theme of recursion happens throughout the book. And the title, the cover page is recursive itself. You have to, there's a little Easter egg in there, you have to find it. Imposter syndrome can be, one of the ways that people suggest curing it is to write about your achievements. Or you write down things that you've done, and they say the act of writing it, but you have to write it about yourself. I learned, or I did this, I learned this, I made this, and this is what happened. By writing it, it makes it concrete in your mind. And that's why I wrote the book. You see what I'm saying? So the book is a cure for me. And so in the very first chapter, or not the very first, this is I think the 4th, anyway, at the very end I said, if you feel like an imposter, we're going to pair on this. So you just pull up your virtual chair and you're sitting with me and we're going to write this together. And that's actually how I try to make it so that the person feels like they're going on the journey with me. And then they can write down, if they're feeling like they don't have any achievements in their life or whatever, they don't deserve it, write it down. You know, write down what you've done and feel good about it. And that's not easy.
We're doing it. We're doing a lot of this virtualization. I mean, like rubber ducky development as well. You know, we come up with a we come up with a virtual partner to talk to and bounce our ideas off instead of using real people to bounce our ideas off. And we're connected worldwide. We have IRC channels, we've Slack channels, we've got everything to talk to people. But it seems like we're spending those more on boasting on each other or like slapping each other down about doing something wrong than just like obviously going up to people and saying like, hey, I just got praised for this. I don't feel like I achieved it. Do you think this, am I stupid here for thinking this is not good enough? Or what do you think about it? I found that when people use my things that I wasn't proud of and seeing what great things they built with them, that's a really good feeling. The other one around is the Dunning-Kruger syndrome, isn't it? Where people take achievements and think they just they take them in without really taking any work on it. They're just like, I deserve having that, so to say. You know, when people don't realize that they're saying stupid things and they're very adamant about it. And it's partly also because we use a lot of like libraries from other people, and we put like 5 libraries together to build something big out of it that people praise us for. You're like, you're such a great program, and I'm like, I don't know what half of the things do that I'm put together here.
Yeah, I just wired that thing up over there. Exactly right. I did that. That's funny you bring that up because I wrote this data access tool, and it was a joke. It literally was a joke. It was a few years after I left Microsoft, and the team, the ASP team, was coming out with some really interesting things. And one of the things was the new system.dynamic in C#. And I looked at that and I thought, wow, I wonder if I could make something fun with this. And I wrote a really interesting data access tool that was 500 lines of code, put it on GitHub, tweeted about it, and I said, I want to get this down as many lines as I can. It became a bit of a joke. And all these people jumped in to help me, and we squeezed it down to 360 lines. And I said, okay, now let's compare this to Entity Framework. And sorry, EF fans out there. But I said, compare this to Entity Framework and tell me the difference. You know, what's the difference? And all these people are like, oh my God, it does at least 80% of what EF does. And it became a joke. And then people started using it. And then more people started using it, and more and more and more. It became actually quite popular. Next thing you know, it's got a name, the micro-orm. And then all these other people are starting to make up micro-orms. And I'm like, oh, that was a joke. I swear to God it was a joke. What are you guys doing? And then, it's funny, Scott Hanselman interviewed me on Hansel Minutes about this thing. And he said, how did you think of putting it together? I'm like, it's just literally knitting together system.data and a few other libraries, system.dynamic. It is nothing, you know what I mean? It's really just ridiculous. Anyway, it was kind of funny.
Yeah, what advice would you have for somebody coming into the market now? I mean, they're in university, they have their CS degree, they probably get job offers every 2 days, but to hit the ground running and stay mentally happy,
I'd say find a mentor. Number one, above all. No one believes me, and I've said this to so many people. And they email me, I'm coming out of university, what do I do? Find a mentor. Find someone you trust, just ask them. Go to any GitHub repo that, and look at maybe the popular ones or something in a language that you use. Find a developer that you really respect. And then hopefully they've got a good 20 plus years on you and professionalism under their belt. And just watch the way they behave. And they will have been through a lot that you don't want to go through. And we do not, this is one of my major causes, we do not have the notion of professionalism that I was, when I came out of college and I went to a job, they immediately put me with a mentor. And I said some stupid stuff in the office, and he would pull me aside and do one of those things. It's like, you can't say that. You sound like an idiot. You don't do that in professional capacity. And I think that's missing, and I think that's why we have a lot of the problems we do.
It's a scaling problem, though. Like, there's no job title for that. There's no. Most companies. This one is actually quite one that is out of the ordinary there. But most companies are like, okay, you're a developer, you're lead developer, you're senior developer, you're architect. You have to go into management now. But you don't have time. You get 20% time to do some extra side project, but you don't get like 30% of your time to mentor other people.
I think business has managed to do it up until now. I just think the tech industry has decided not to. They take these kids out of school, and people like me that come in, and there's a clash. There is a clash. And people behaving like idiots, dropping F-bombs on slides. You don't do that. And I know how that sounds, but you don't do that. You don't go on stage and represent your company and say dumb things. That's just stupid. And there's nobody around to tell people that. So people think, oh, I'm being cool and interesting. And no, you're an idiot. And you come across like an idiot. And I'll say that point blank to anybody, and I have. It fires me up because you want to communicate to everybody in the room. You don't have to stand there with a tie on. This is what everybody comes back. Oh, what do you want us to wear, the blue Microsoft shirt? No. Just be you. You know what? You and I might sit in a bar and let some things fly, but you don't do that with people that you don't know. You can't have a social read on them, and you can't meet eye to eye. I know what I can say to you, and I know what I can't, But if we had a room of women and men and different cultures in here, no way. I think you have to raise the bar. Anyway, that's my thing.
I found that, I speak a lot publicly, and I found myself just thinking about that. Before I start talking, I actually become easier to understand. My pace of speaking is better just by avoiding it's very easy, especially for a non-native speaker, to use swear words to pretend to know more about the language than you do. Because a swear word is something that only a native person would normally use. So it's a lot of people to mask their knowledge of a language or their lack of a knowledge of a language with that. And there's nothing, as you said, there's nothing proud about this. There's nothing to win about this. It's like, as I kept saying when somebody used also outrageous slides, and I'm like, yeah, you got people's attention, but it's like kicking somebody in the shin. You have their attention, you don't have their support. And it doesn't help that we're actually trying to be the right person all the time. We have to be the kind person, I think. I think kindness is something we don't do enough.
Sure, or just basic respect. Basic respect, period. That's it. And it's funny because you talk to someone like Paul Stack, Paul Stack, very, very forward guy. And when you talk to people from different countries that have different senses of swearing, to them, it's you drop an F-bomb or something like that, it's not a big deal. But there's a lot of people that don't believe that, and those are the people I think deserve respect as much as anyone else. So.
Well, in respect with people's time, I think we should wrap up, and it was great talking to you. Thank you very much for coming.
That was fun. Nice to talk to you as always.
See you soon.
Yep.